So the more one studies, their grades will, tell me? Increase. I'm going to put an I there. The more one diets, their weight will decrease. We'll put a D there. The longer one diets, the amount of weight loss will increase. The more exercise, the more a person exercises, their muscle mass will increase. I think this is trying to tell me something. The more a person exercises, their fat mass will decrease. Geez. The more a person jumps rope, their heart rate will increase. The more a class talks, the teacher's patience will decrease. I'm going to put that, make that bold, red. No, I'm kidding. I wish I could highlight it. Kidding. The more a person reads, their vocabulary will increase. That's an important one. If ever you want to know how to start using bigger words, it's reading more. All right, so here's our discussion today. We talked about scatter plots yesterday as well as the line of best fit. So we're just going to make sure you really know it today. We'll spend a good portion of the rest of the week reviewing both linear equations and scatter plots to get you ready for a strong test grade at the end of the week. So you've got some fill-ins. An effective way to see a relationship in data is to display the information as a scatter plot. And a scatter plot shows how one piece of information is connected to the other, like the warm-up examples we looked at. The more you exercise, the more muscle mass you will get. Two separate things, but they are connected. It shows how two variables, so we eventually will plot a point, and to plot a point you need an x-coordinate and a y-coordinate. So it ultimately shows how two variables relate to each other by showing how closely the data points fit to a line. So that's that line of best fit. We wrote down that vocabulary on Friday. So here we have a table, and looks like this table is looking at the number of tornado occurrences between the years of 1950 and 1995. And right away, just by looking at that bottom row, number of tornadoes, what can you see? What can you see there? What does it look like the trend is? Increasing. So as the year increases, the more the number of tornadoes occurrences increases. Now, that could be a number of different things. In 1950, we didn't have the technology to read all of the tornado occurrences like we have now. Every time we get two different airflows and it looks like a spiraling could occur, our Doppler picks it up. So there are different reasons for that, but whatever the reason is, there's definitely more tornadoes happening. So what I'd like for you to do is take a few moments to use this chart to plot a scatter plot. And we have it set up for you. What do we call the axis that runs from left to right, runs horizontally? Is it the X or the Y? The X runs horizontally. So the years are going to correspond with your X axis and your X values. The number of tornadoes, that's going to be your second value in your ordered pair and correspond with your y-axis or your y values. So take a few moments to plot those points, please. And then we talked a little bit about this on the last slide, but do you notice a trend? What looks like, if you had to define this as a positive, negative, or no trend at all, what might you say it was? I hear whispers. None? What do we think? It looks a little scattered, but the general direction of this is going upward. Thank you. I heard someone go. I can't whistle, but I saw you. Thank you. They did that. So as it moves up from left to right, what kind of trend do we call that? Positive. Very good. So there is a trend. It's going in the general upward direction. So there is a correlation. All data has some sort of correlation, or has a name for the correlation, should I say. Scatter plots provide a convenient way to determine whether a correlation exists between two variables. We call it positive when both variables increase, like the slide we just looked at. As the year number increased, the number of tornadoes increased. Positive correlation. And I agree with my student in the back. It was a little scattered. There wasn't a clear upward trend, but it was moving upward from left to right. And then we have a negative correlation. That happens when one value increases and the other decreases. That would be like the number of days you exercise in a month, and hopefully, if you're trying to lose weight, your weight will decrease. So as one increases, the other decreases. And then there are times when there's little or no correlation. So that might be your age and the number of hours you watch television. There's really not a clear connection, because I know 10-year-olds who watch lots and lots of TV. I know 10-year-olds who don't watch TV hardly at all. I know folks my age in their 30-somethings who don't watch hardly any TV. And then I know 30-somethings that watch a lot of TV. So there's really no connection between the two. And that would be an example of little or no correlation. So here we have 3 examples of scatter plots. What would you call this first one? Positive. In order from left to right, it's moving upward. So as one value increases, the other increases. There's your negative correlation. As one value increases, the other decreases. That might be like miles driven in a car and then gas in your gas tank. The further you drive, the less gas you have. So as one increases, the other decreases. And then here's our little or no correlation. So we're going to do some examples. Here you have 3 different scatter plots and 3 different situations. So can you, or what I'd like for you to do is match each of these 3 scatter plots to one of these situations. And you can just write the number 1, 2, 3 underneath or over its match. So we have one age and age and height. Are they connected? And I'm going to say between the ages of 0 to maybe 16, birth to 16, because I know we can make an argument where it plateaus. Age and eye color, is there a connection? Would it be positive, negative, or no connection? And then age and time needed to run a certain distance. And again, let's think about from birth to 16. So, looks like the first scatter plot is a little scattered. There's no really distinct trend. So which of these 3 situations is really not connected? 2. So there's no correlation between your age and your eye color. So that first graph represents situation 2. And then the next one, there's a general positive trend. And as your age increases, so does your height. And then yes, when you get a certain age, it just plateaus. You don't grow any taller, and then you get older, you even shrink a little bit. But generally from birth to age 16, as your age increases, so does your height. And then that last one, as your age increases, the time you need to run a distance should decrease. Because though my 2-year-old can possibly outrun me now, especially after work if I'm a little tired, but generally she can't outrun you guys. So as your age increases, usually you can run a little quicker. So there would be our third situation. Yes? A question. Okay. Okay, but you got it. Awesome. Sometimes points on a scatter plot are represented by a trend line or a line of best fit. You can study that line to see how the data behaves, and we can make predictions based on that line of best fit. So if we went back and looked at that tornado situation, we could, based on the general direction, make a prediction that the year that left off with was 1995. This year we could say, well, we're going to have at least as many tornadoes in the entire United States as 1995, probably more, based on the general direction of the trend. So we're going to look at some examples. We're going to find this line of best fit for the scatter plots we made on that first page. So go back to that tornado situation and just draw in your trend line. It doesn't have to pass through all of the points or any of the points at all. We're just giving the general direction of those points. Please do that now. So if you were to go back, here's your trend line. So let's make some predictions. Here we are at 2014. About how many tornadoes might we expect to see this year? I'm sorry? Over 1,000. Because based on that trend line, we can say it's may not fall exactly on that line, but it's in that general direction. What about in 2005? Because that one crosses right on a point there. About how many tornadoes, according to this, might have occurred in 2005? I'm sorry? 1,000. About 1,050, 1,100, right about here, somewhere in that range. So even though they don't give us those points, because of this trend line, we can make some predictions. And then you can see where that cross-section happens to do that. And you guys have answered this question already. If the trend line continues, we predict there will be about 1,200 tornadoes this year or next year. And we're going to talk about strong correlations and weak correlations. And just a little while ago, one of my students, one of my gentlemen towards the back said, well, doesn't really show that it's going positive, it looks more scattered. Well, we're going to give that a name. If it's going in the positive direction, but they're scattered, like that first example, we're going to call that a weak positive correlation. If they're more together on that line, we'll call it a strong positive correlation. And then we have a weak negative, again scattered, but going downward generally speaking. And then a weak negative and a strong negative correlation. Alrighty, so I didn't mean for this to pop up. I wanted you guys to record those grades. But I am going to have you practice. We're almost there. If you will take this data, the study time, and we're going to form a relationship between the hours studied and our grade earned on, we'll say, a quiz or a test, perhaps our overall class grade. And though this is not a strong correlation, there is a general trend. What is that trend from left to right? As one increases, the other seems to increase. So if they both increase, what kind of trend is that? Positive. Awesome. So please practice plotting those points. And then your last example, and I'll have you guys complete this, is another where we're going to practice plotting those points and determining what kind of correlation that is. So as you can see, when we do connect these points, they form a positive relationship. So according to this, and I would totally agree, that the more you spend studying, within reason, the better you do in that class. And then here we have a negative correlation, and you guys have graphed these points for me already. Days worked out per month. Looks like the more you work out, then you see a decrease in your weight. And that would be an example of a negative correlation. So this concludes our notes on scatter plots. Please refer to this as you prepare for future test quizzes and assignments.